Well, hello, CP Algebra 2. Welcome to 5.2, Part 1, Evaluating Polynomial Functions. This stuff is easy peasy as always. Alright, so let's get right on to it. First thing, we are talking about polynomials once more, and we are going to get into some terminology. Okay, polynomials, we're stepping it up from parabolas into just polynomials. So one thing we have is the degree. The degree of a polynomial is the value of the largest exponent. Okay, so the largest exponent, myself, I have a bachelor's degree. Okay, that oversees an associate's degree, a high school diploma, things like that. So it's like your degree is the highest amount of education perhaps you have at the time. So that's basically the degree, all right, the highest exponent. The term without a variable is known as a constant. Okay, it constantly stays the same, hence there's no variable. Okay, and polynomials are in standard form when their exponents are in decreasing order from left to right. So decreasing order, and that again is from left to right. Alrighty, let's look at some examples then. Types of polynomials. If we have a 0-degree polynomial, so maybe this is someone who has no high school diploma, anything like that. Its form is just, it's a constant, okay? It's the letter, so if we have variables, C. Boop. Constant. Alright. An example would be like the number 5. Okay. It's a constant. Now, to be clear here as well, it's actually to the first power. Okay, just a little trick here. So note 5 to the first is actually 5. Okay. So it has, I guess, a first power there, making it constant. But notice, no variables. Alrighty, no variables located there. Alright, first chapter or second chapter, we started looking at linear functions, and those have a variable such as x. So functions now, we're going to use function terminology. F of x, which is really y, this just means, okay, some constant times x, okay, or some coefficient times x. Now notice we have an x. Alrighty, it's there. It's to the first power. But anything like f of x equals 2x. Another example, f of x equals 3/1/3, maybe x plus 2. Okay, these are linear functions. They create, hey, a line. All right, hence being linear. Last chapter, we looked at quadratics. You should recognize those are things with x squared. So if you have f of x equals some constant, okay, a is typically what we use for constants, x squared, okay, it's anything like that. So for an example here, if you have, 6x squared plus 2x plus 1, all right, this is in standard form because they are decreasing the exponents, okay. And also, we have our highest exponent, our degree of 2, first. Okay, a cubic. Okay, cubic functions. They are to the third power. So a times x to the third. Alrighty. So again, x has to be there, or some variable needs to be there. To be clear, let's just look at one. Let's look at f of x equals 1/2 x to the third. Okay, it's x to the third. So therefore, right off the bat, it is a cubic function. Okay, it's to the third power. Try to be a little neater there, perhaps. Oops. Big old 3. All right, quartic, and then there are other ones, but quartic, that is, you might be getting the idea, that's something to the 4th power. Now keep in mind, you can have other terms like bx to the 3rd plus cx squared plus just a constant. Okay, really, this stuff is just extra degrees. Okay, and all you're really needing to be a quartic function, you need x to the 4th. Cubic, you need x to the 3rd. So an example, f of x equals 2x to the 4th, maybe plus 4x. Okay, you don't need all the other ones. Its big idea is that, hey, I'm quartic, I have a 4th power. All right. Things that are not in the polynomial club. All right, all of these are polynomials. They're all buddies. Things that are not are any functions with a negative exponent. Now, recall last chapter, they might look like this here. You might have 1 over x. Because really, what's that mean? Hey, the x is downstairs. That means technically at one point, it was an x to the minus 1. Okay, examples, just like that one there. 2 over x to the 3rd, or x to the negative 3rd, or 5 halves x to the negative 3rd. Okay, that negative power is like, yep, I'm not a polynomial. Different. Okay, it doesn't always have to be 3. I just had to pick 3. Okay, fractional exponents. Another thing that are no good in the polynomial world. So x to the 1/2, x to the 3/2, anything like that. You kind of get the idea there. 2x to the 7/3. Okay, fractional exponents. Any square roots, so square root of x, cubic root of x, and things like that. Examples, these all pretty much are examples. Basically, if you see any of these things, you know it's not a polynomial. And variable exponents, say you have a constant to the x power, so x cannot be a power. No x as a power. All right, otherwise it's not a polynomial. Okay, so other things to consider. You are going to be identifying these just like you did before with identifying linear functions. Now we're going to see if it's a polynomial function. Alrighty, so let's check it out. Okay, I see x to the 4th. All right, no roots or anything like that. 1/4, I see a fraction, but it's not an exponent, sorry. Okay, it's a fraction, but it's not an exponent. So fractional exponents mean no good. So we are still a polynomial, and 3 is just a constant. Yes, its degree would be 4, the highest degree we have. Type, you would say it's a quartic. And the leading coefficient, that's the number in front of the largest variable. Okay, in our case is 1. All right, the leading coefficient, all that stuff from before. Just a quick example for this one here. So this tells me it is a polynomial at the time, but then we move to the next term and we see this root, and right there is like, hey, Mr. D said we can't have square roots to be a polynomial, so this is not a polynomial. None of this applies. All right, you could certainly look at these two to try them out. I'll do that in the extras a little bit later. All right, the last thing I do want to show you is evaluating. All right, and this is so simple yet always mixed up. Why? Because people are not careful in their calculator. I've been emphasizing that all year, and it still amazes me. Students just kind of run through, don't take their time, and they get funky answers, okay? Again, all you're doing is substituting values of x into this equation. So, again, f of 3, you do not do anything, you don't operate with this, okay? It doesn't need any operations. It's just like someone at the store saying, hey, what is f at 3? Okay, it's just a question. It's just saying the function at 3 is, and that's all your work over here. That's all it's saying. So what you are really only doing is you're putting 3 in to where the x's are. And yes, there's a few of them, so you need to take your time. So this is 3 to the 4th, this will be 3 to the 3rd, this will be 3, okay, plus 8. Yes, I need to get out my calculator here and carefully substitute all of that in there, okay. Putting all that into my calculator in one step using parentheses, you should get 23, okay? And this is just your answer. F at 3 is what? It's 23. Do not divide by 3, okay? This is what I see students do. They're like, oh, well, now I need to divide by 3, okay? And I'm like, no, okay? You don't do that. You do not need to divide by the 3, okay? This is just your answer. F of 3, which is really just y, okay, is 23. Easy peasy stuff, all right? Just substituting. You certainly should be able to practice evaluating and hopefully classifying, and that's what we will be doing tomorrow. And then part 2, we'll get into graphing and such. Before you head out, your essential question, of course, is how do you evaluate polynomial functions, and give an example. Okay, give one example. Alrighty guys, have a fantastic day. I'm going to cover the extras here now.